So today we will continue the introduction of the hydrostatic bearing. Last time we have talked about the configuration for the hydrostatic bearing. So we have the thrust bearing, we have the thermal bearing. So for the thrust bearing, usually is for the design of the slide table. Okay, so here is the slide table for the grinding machine. Yeah. And for the opposite side slide table, usually used in the milling machine and turning machine. Okay. So for grinding machine, the cutting force is very small, so you can use the open guideway system. Okay. For the milling machine and the turning machine, the cutting force is 10 times and 100 times bigger than the grinding machine. Therefore, you need to have a closed form grinding slide table. Okay. So you need to have a design of a closed form slide table or closed form thrust bearing in this case. 大部分来讲的话，就是磨床切削力比较小，所以可以用开式的导火器。那车床跟铣床的话，切削力比较大，所以它必须要用这个闭式的导火器，在它的这个工作台的部分。So today we are going to introduce the flat deck bearing. So last time we also talked about the configuration for the spindle. The hydrostatic bearing arrangement in the spindle, especially for the grinding spindle, milling spindle, even the turning spindle is the same. So normally you have those three types of the spindle bearing configuration. So this one is not useful. So we can ignore it. So there's no practical application for this one. So here is the flat deck bearing, is a thrust bearing actually. So here are some different configurations for the thrust bearing. So in this case, you have 4 resets in this thrust bearing. And this is also the thrust bearing design, especially the spindle. So each individual is a unique or single reset type. So in this case, for the thrust bearing here, you have 1, 2, 3, have totally 8 resets in the thrust bearing. So this is annular multi-reset thrust bearing. You can look at this one. Actually, the transparent beam. Okay. Or you can see here is the stem. This is the transparent. So this is the actual design. So the number of the heads, depending on the size or dimension of the transparent, the outer diameter, the inner diameter. So usually you have I would say you have this kind of multi-reset design because it's better for the tilt moment to resist the tilt moment. 通常的话都是会用多油枪的设计，像这个指挥手组的设计，通常都是一般来讲比较常见的是468。The hole you see here is the inlet hole to supply the lubricant. 这个孔就是我们的路由孔。So the oil was pumping into the bearing recess, so you build up the pressure distribution. So the pressure distribution here, you can sustain the external loading. So this is the idea to show you when you have a tilt angle. So you have a different film thickness between the two sides. So the pressure distribution will be different. 所以就是多相似的好处就是当你起步一个斜角的时候，它的因为屏幕间隙不太一样，所以它的压力温度也不太一样，它会让你有助于恢复你原来的姿态，所以是可以抗起这个力矩会比较好，多相似。Although you can also see the design with one reset in the angular transfer. 当然也很少数的设计你会看到它的单一一个油墙，是一个油墙，但是这个对起步力矩来讲是比较不好，所以一般来讲，我们都会就是用很多个 multi-use， 就是很多个油枪的设计。Okay, so the title here is that the multi-use over tilt resistance. Okay. So if the trust bearing with the single reset has virtually no resistance to the tilt moment. Okay. Therefore, usually you will have a multi-reset design. Especially in the big especially in the big rotary table design. For instance, this is the vertical turning machine. So this is the typical hydrostatic transparent design. So you have multiple resets in your thrust direction. 像这个的话，就是有多油枪的设计。Because for your workpiece, it's not always uniform shape. Right? So the center of gravity is not always in the center. 对我们的弓箭来讲，不一定是规则，所以重心不一定是在中间。So this is a flow type bowling machine. So flow type bowling machine from Italy. It's the same for the guideway system here. For the guideway system, this is a linear slide table. For the guideway system here is also hydrostatic bearing. This is a hydrostatic transparent design. So you see here is a closed form guideway system. Okay. This one is closed form. So you can for the closed form hydrostatic guideway system design, you can resist the vertical loading and also the radial, the loading in the radial direction. Okay. So the yellow one is the hydrostatic bearing type. This one, and this one. So this one and this one, hydrostatic bearing design. So this is the zoom in for the guideway system here. Okay. So the yellow one is the reset. And for this large machine tool, the reset is made out of brass, okay, 黄铜做的. So and then the reset was fixed to the cast iron structure. Okay. 像这个就是封闭式的，对不对？ 所以它可以承受侧向力，可以承受垂直方向的重力，因为它这边跟这边上下都有低气压轴承的油箱。So here you can look at the transparent. So it's also the design of a multi-reset. Okay, you have a 1, 2, 3, 4, 5, 6. In the axial direction, you have a 6 bearing reset in each skyway. Okay. 所以这个也是多油箱的设计，所以在这个工作滑台的方向，你有6个油箱，所以它可以抵抗起伏，所以重心不是在中心的位置，是最大的方向。So this research was met by Ross. 这一个的话就是颜色不太一样，这个也是铜，只不过是零青铜。The reason was met in Ross is because when the hydrostatic bearing is not applied to pressure, you will have a contact with the bearing recess between the bearing recess and the guide wave. So still there are some waves existing between these two surfaces. 我们会把一些要求的油箱做成桶的话，就是它的硬度比较低，它比较冷。那我们没有打油的时候，我们的轴承还是会停在轨道上面，还是会有磨耗。那我们希望它的磨耗是发生在油墙。那油箱的话，我每一个都可以把它拆下来。我大概2、3年维修一次，就是把磨耗比较严重的就把它替换。So this is individual bearing test. So you need to have a hand scratch for the bearing C. Okay. 一家投资的风油边其实都要采花，然后来保证它的贴合率。贴合率大概要85%以上，当然越高越好，通常一般都会要求到90、95，所以这个大部分都是要用采花。So this is another example for the multi-reset in the truss bearing design. Okay. So there's the rule of thumb. So in the direction of the movement, usually you should have at least two resets in this direction, in the moving direction. Okay. So let me see. So if the slide table is moving in this direction, which means the transferring in this direction, at least you have two resets in the moving direction. So this is the rule of thumb for the design. 通常是在移动方向至少要两个油枪，在工作台上面。对。And this idea for the multi-research design applies to the aerostatic bearing as well. Okay, so which means that the multi-research head design for the thrust bearing applies to the hydrostatic bearing and the air bearing. Okay. 所以这个设计的方式是，不管是静压还是气静压都是一样。So this is another example for the nuclear structure facility. You have a hydrostatic bearing thrust in the thrust direction. 这个是在核能的设施，它有那个低气压流程，在那个推方向的地上。Another one is the machine tool, the grinding machine from the United States called Landis. This is kinetic Landis company in the United States. So the grinding machine for the grinding machine tool is made of hydrostatic bearing. So this is the shaft. And this is another example of the rotary cable made of the German company named Zoller. Okay. You have here thrust bearing 1, 2, 3, 4, 4 resets thrust bearing, and German bearing here you have also 6, I think. There are 6 bearings at the German bearing. So you can have so the diameter is half meter in diameter. You have the dropout smaller than 5 micrometers. Here is another example for the air bearing spindle for the Westwick. This company is from the United Kingdom. So this is a finding and drilling spindle for the using air barrier to drill a hole in the PCB board. 所以这个是气静压轴承的装潢机，装那个印刷电路。So Westwick is world famous air bearing spindle company. So for this spindle, you have a maximum speed to 200,000 RPM. But you can check out the catalog, product catalog from the website of this company. I think for the moment they have a product with the maximum speed is 500,000 RPM for PCB drilling speed. 通常几十万转的这个装补机，大部分都是机器人。像我们的东台的机器压轴承，它中台也做机器装补机，他们的也是一样，他们其实就是刚开始是跟温室品牌，现在是国产。So you see here you have the price ratio of 5.65. The structure is exactly the same as we have been showing you in the video for the air bearing speaker for the DC-DC machine. So for the manufacturing of the hydrostatic bearing or aerostatic bearing, for the truck bearing it's easier. Okay, for the joint bearing it's a bit difficult. You know, for the dimensional tolerance control. For the for the air bearing especially because the fuel jet thickness is small, usually a few microns to 10 to 15 microns. So the precision, the accuracy of the dimension for manufacturing the component is very important. 特别是在气静压轴承，它间隙通常是只有几个 micron 到十几个 micron，所以它的尺寸精度是非常重要。所以供应商要能够做到公差范围的精度。So this is a typical figure for the journal bearing. So the manufacturing of the journal bearing is a difficult one. And usually, I mean, for the good design of hydrostatic bearing, when you supply the pressure, the bearing surface will not have any contact. So therefore, you should have a guarantee. So for long service life without wear between the bearing surface. 通常好的静压轴承设计的话，它工作起来是完全没有接触，所以其实不会有太大磨耗的问题。One German company, once we show you called the Monfort, they have a guarantee for the hydrostatic bearing product from the turning machine. 5 year guarantee, no free. You can look at the So the hydrostatic bearing in the turning machine, there is a 5-year guarantee for no way. Maybe we can look at the video again to remind you some example for that. To show you before, this is the turning machine from Norfolk. The hydrostatic bearing design in the Z-axis of the machine. So there's a guarantee for the hydrostatic bearing with a 5-year guarantee of no way. So normally the material for the bearing type is mild steel. Okay.大部分都是中碳钢both transparent and gel bearing. So this is the air bearing with the slug restrictor. This is the slug restrictor. So this is the component for the gel bearing. Here we talk about the bearing material selection for the hydrostatic bearing. So for the hydrostatic bearing, you have a higher supply pressure. Usually the soft bearing material may extrude or deform unacceptably. Okay? And also for the hydrostatic bearing running in very small film gap thickness, you will have a higher temperature generation between the lubricant and the bearing surface. Okay? So the material should be temperature stable. also sometimes the hydrostatic bearing should move in high precision. The material should be selected with dimensional stability and easy of manufacturing. Okay. And also, the material should have corrosive resistance. And for the air bearing, especially because sometimes you have the intact air with moisture. So the material for the air bearing should should be the corrosion resistant.对，气压调整的话，有时候吸入的空气会有一些水分，通常是机会不大，因为我们有那个它的进气系统里面有干燥器，所以其实会干燥过在气，但是还是有可能，即使没有开机的话，温度改变还是会有湿气在轴承里面，它其实会有那个生锈的。Actually, usually we use the material. Normally we use the mild steel for the bearing type because the bronze and the other material is more expensive than the mild steel. 实物上来讲，中小型的液压轴承我们其实都用碳钢做，不会用黄铜。大型工艺才会。因为中小型的液压轴承的话，通常整机的单价比较低。你用黄铜做的话，价格就非常高。黄铜的价格可能是碳钢的3到5倍，不一定要看市价。大型工具机我一台几千万甚至上去，所以他们才会用黄铜做那个。大力车有，大力车那个一个工作台可能是500-600万，甚至更多。For the air bearings, the material selection is more or less the same as the hydrostatic bearing, but the manufacturing tolerance for the aerostatic bearing is more accurate than the hydrostatic bearing. 加工的公差来讲，空气轴承会比液压轴承它的那个公差更小，所以更难加工。加工厂真的这样能够做到尺寸公差。 最低的要求，不能做到了再给你就不能用。So we can look at the detail of this. For air bearing, usually you apply in a small precision machine tool. For hydrostatic bearing, usually apply in a large machine tool. And also you have different low capacity. For the hydrostatic bearing, you have a higher low carrying capacity. For air bearing, you can run in higher speed. So the coefficient of friction for the air is 100 times smaller than the oil hydrostatic bearing. Therefore, for air bearing, you can easily run in 100,000 RPM for the air bearing speed. But for hydrostatic spindle, usually the maximum rotational speed is about 3,000 RPM. 差别就是空气轴承的话，空气粘度很低啊，它是油的几百分之一，所以它可以在高速运转，不会有很大的影响。所以你看，刚刚我们看的PCB 端口机，会 swing 的产品可以到50万转，但是对液晶压的主轴来讲，通常市场上你看到的几乎都是3000 RPM 以下。So I think about 10 years ago I attended a conference in the United States. There's one company presented the hydrostatic bearing spindle designed and manufactured by the company, and it can run about 20,000 RPM. But the cooling system for the spindle is nearly half, occupies nearly the space, half of the capacity. 十几年前，大概是12年前，我们去参加美国的研讨会，美国的经济工程研讨会，有一家公司就发表他们做的液晶压板，它可以转2万转，但是它的这个散热的装置大概是教室的一半空间，它就是为了要把它那个摩擦产生的油膜摩擦产生的热，要把它降温的话，它那个散热装置的像教室空间这么大。Therefore, in reality, for the commercial product of the hydrostatic spindles, usually they are running less than 3,000 RPM in the market. 所以大部分来讲，液晶压主轴在市面上你买得到，大概都是3000转以下。So here are the some advantages for the air bearing. So you have extremely low friction, it's full running and low power loss. capable of running a very high speed, low or nearly zero wear rate, and low noise and vibration level. So this one should be this one will be guaranteed if you can have a very stable design for your numerical instability. And if the air bearing is capable of running very high speed and very low temperature operation. Okay. So and for the aerostatic bearing, you can run in with the air as a liquid, or sometimes you can use nitrogen as a liquid. 大部分都是用空气轴的，或者叫气静压轴，大部分都是使用空气，因为空气最便宜。除此之外，其实还有其他的气，像我们这边这个是氮气，那也有一些特殊场合需要用到氧气。And this is the disadvantage or drawback for the aerospace. So you have limited supply pressure, only 4 to 6 bar. Normally, or usually, the supply pressure for the air bearing is with a maximum 5 bar, no more than 6 bar. In order to avoid the pneumatic instability, air handling instability. And for Olympics, yes, for aerostatic bearing are vulnerable to pneumatic handling instability. Not always, but you should design very carefully for the reset volume. 气压轴的最大的问题就是它的不稳定性。如果有枪支，像小孔节油器就会有气小小的空间，有空间就会蓄压，蓄压就容易变成是可压缩性，就会有不稳定。For the air bearing or the aerostatic bearing, we are talking in this course or in this classroom is about the traditional air bearing. It's not the porous air bearing. Okay, this is a totally different design theory. So there are two different types of aerostatic bearing. One is the traditional air bearing, like like air bearing we introduced in our textbook. So it's transitional. I would call it transitional air bearing. So you have so for the porous air bearing, usually you just have a porous bearing head design without the restrictor. You don't have the restrictor.其实气垫压轴有分两种，一种是传统讲的气垫压轴，你要设计枪式跟设计节流器，还有一种是比较新的，大概最近是在流行，它叫做多孔性，它其实是用多孔性的材料，所以它的轴承做起来就通通是只有轴承枪式，然后它没有节流器。那这个的话，它的刚性就会比传统的大不了，但是这个的困难就是，你怎么去，它这个是要用搅拌配方，然后去烧出那个中层枪那个中层电出来，困难是那个配方。台湾现在只有一家会做，而且只会做推手。我们现在那个半导体，友达、奇美这个一晶面板，它那个玻璃面板或一晶面板做好之后，它要搬运，它没有办法接触在那个滚轮上面去搬运，所以他们就是用这个气垫压轴承的这个台子，比方说我这个面板尺寸就跟这个一样，我就做一个气垫压轴推手，就是做这个尺寸。那我一直吹气，所以呢，搬运那个一斤的面板就是浮在上面的，所以国内目前有一家会做，它那个其实是多孔性材料加上其他的材料要去炉子里面烧，所以那一家厂商原来是做陶瓷，他把它转做科技陶瓷，就是做气垫。只推手的他没有做，因为他说他光那个手顶轴承他没有做，他只做指推，所以他就花掉7、8千万澳币开发那个适配方。现在有达光电的那个就已经都不是买国外的，现在通通都这样买。So this is the scope of the various discussed in this course. 所以我们这门课探讨的是传统的空气轴承。 So if you are interested, you can using the keyboard to look at some video in YouTube。有兴趣的你可以上那个 YouTube 去找一找，中国静压的跟传统的这样有一些影片。So we take a break. So this is all the material in chapter 1. So chapter 2 we will start to introduce you some basic theoretical background of the hydrostatic bearing. So basically we want to calculate the flow rate. So we want to calculate the pressure distribution. We want to calculate the load capacity and the stiffness of the bearing. So that's the important thing when we apply the hydrostatic bearing in machine tool design. It's a mechanical property, mechanical performance should be fulfill our requirements. So here are the content of this chapter. So starting giving the introduction, and we will discuss the viscosity of the lubricant and discuss about the unit applying the hydrostatic bearing, and we will also talk about the compressibility because we are talking about the air bearing and hydrostatic bearing. So we need to distinguish the compressibility between the air bearing and the hydrostatic bearing. For air bearing, for the air as a lubricant is compressible when you have a supply pressure more than 6 bar. Okay, and more importantly, you will have pneumatic handling stability when you have a supply pressure more than 6 bar for the transition and 可以啊，过性的话，我们会去讨论，特别是空气轴承的部分。传统空气轴承的话，就是会有气水不稳定的现象，所以它限制它 公压大概最多就是不会超过6bar，通常是5bar，大部分情况。And then we will later discuss flow between the parallel plates. So this is the basic theory for the hydrostatic bearing. Hydrostatic slide thrust bearing. Discuss the lubricant flow between two parallel plates. One is the sliding surface, another is the guide rail surface. So then we will also have a theory to calculate the combined effect for the pressure induced viscous flow and the velocity induced viscous flow. So our applied pressure will push the lubricant to have a movement between the bearing surface, two bearing surfaces. So that is the pressure-induced flow. And for the slide table, you will have a movement, the moving speed provided by the servo motor. So it is an extra effect from the velocity-induced flow. 其实轴承如果是靠供油压力去供应的话，它就是我的压力把润滑油挤出来，我的流动是压力造成的流动，供油压力抗不打出来。那如果在事物上来讲的话，不管是直线工作台、旋转工作台，我的四部马达，我的马达会带动额外的速度去转动它，那也会造成润滑油有额外的流动，所以我们会有一个复合的效果，就是压力造成的流动跟速度造成的流动两个合在一起，才是真实的一静压轴承流体流动的情形。And later we will discuss the lubricant flow through the restrictor. Okay. And then we will discuss also, we will introduce you several different types of restrictors applying hydrostatic bearing and aerostatic bearing. I would say the majority of the restrictors can be used both in hydrostatic bearing and in aerostatic bearing. But you have, I would say, 30% of the restrictor can only be used in aerostatic bearing. 有些结流其实两个都可以用，气静压力、静压力。有个笑话，张师大有位老师在跟做一静压手的时候，他从来没做过，他就把他的气静压手的打了。有些节流就是可以用，对，这个完全没有问题，但是你的参数一定不对，你的间隙是不对，这个对计的话没办法，直接把润滑油换掉就可以。And then we will also want to know, for you as a design engineer, you want to know the pressure distribution and to calculate the recess pressure. Okay. As an engineer, graduate in the university, graduate from the graduate school, and the capability for you is to of the hydrostatic bearing. That is the important thing for you to learn in this class. Okay? You need to know how to calculate the bearing and area, the recent pressure, and the flow rate of the bearing, and also the temperature rise for the viscous friction, and the pumping power for your vibration, and the total heat generated between the bearing surface. Okay? So this is the important thing. You know how to calculate the recent pressure. Okay? And you can calculate the bearing load capacity. Because that is the key for you to design a hydrostatic bearing for application in machine tool. You need to have you need to guarantee your design dimension of design the design of the dimension of your bearing head can fulfill the load capacity. 所以我们其实也要去计算我的油箱尺寸跟它的油箱压力都很复杂。当然你要去选风压，风压力。Later we introduce the concept of normalized phase. So this one was useful for the fluid mechanics. 在流体力学常常我们会用无因式式，因为我们做流体力学的实验，常常是理论推导，我会去做一个尺寸一样的来去测它的功能。那我这个结果如果是我的构造是一个特定的形式，那我这个尺寸如果是推导到不一样的尺寸，是不是可以适用？那适用的方式的话，就是我们需要用叫做正规化，或者是叫做无因式化的数据，就是把你的实验出来的结果，把它弄成一个无因式的一个公式，就表示说我这个其实我这个轴承的特性跟尺寸无关，只要是这个形式、这个构型都可以。这是流体力学，因为流体力学常常像我们设计飞机、设计潜艇一样，我不可能一开始就做全尺寸的去做设计，我一定是用理论推导完，我去做一个缩小的模型去做设计。那缩小的模型，它就可以相似我全尺寸特性会是怎么样。那为什么缩小的测出来的结果可以把它推演到全尺寸？它的结果不是一样是正确的。那我们用的一个观念就是无因式的概念，就是我的结果其实是跟尺寸无关，只要构造这个样子出来的结果，就会跟这边类似。所以它这个是叫正规化，或者是叫做无因式化 （normalize）。所以我是把我的尺寸去取代，可能是最大的长度、最大的宽，所除出来的单位就不是尺寸，它是一个无因式的。那我这样子缩小模型出来的结果的话，就可以推广到不同的尺寸。说我只要是同一个构型的话，的轴承，它的性质就会类似。其他的尺寸都只要是构造类似的，就不需要再去做，直接拿我的结果用。 And finally, we will have a summary for the hydrostatic bearing and elastic bearing. So you will know the derivation of the formula in this book, all based on the hydrostatic bearing. And the result of the air bearing, aerostatic bearing, is just give you some formula, so you don't have any deviation for the aerostatic bearing result.虽然它是书名是把气静压轴包含在这里，但是作者的前一本书是写整本都是一静压轴，所以他这一本其实推导也全部都是一静压轴，他只是把气静压轴的那些列在最后。所以我们不会有气静压轴的推导的结果，但是你会有它的公式出来。Due to the complexity of the aerostatic bearing, so the theoretical derivation of the formula is more difficult than the hydrostatic bearing. 因为气体的可压缩性，所以理论推导的部分，气静压轴的其实会比一静压轴困难非常多，就是公式推导的部分，计算上也是会更复杂。像我们以前早期我们没有 N 型，是念博士的时候30年前，那是一个 N 型，还不是 PC 版，在工作上面可以用，那个一套对，只有你去买工作站才可以用。那个时候我们要去解这些方程式，都要自己写数值分析的，所以我们解压力分布啊，解流量啊，这些都要自己写数值分析。所以我们那个大三，蔡立人老师有开那个数值分析的课，以前我们都要去修数值分析的课程去写的，算这个解联络方程。那你就会发现写气静压轴的程式的话就比较困难，那气静压轴相对比较简单，因为我们的应用范围都是不可压缩，不可压缩的写数值解非常容易。对。So here are the introduction. So for the hydrostatic bearing, there are two important parameters. The first one is the bearing flow rate, and the second one is the fulcrum force. Okay. And for the hydrostatic bearing, we have a flow rate passing through the restrictor and passing through the bearing. And the fulcrum force on the bearing surface is acting on the bearing surface. So, and then the lubricant is a steady flow and you have a viscosity intensity. Maybe let us look at the previous chapter for the pressure coming from the power supply system or fluid supply system. Okay, so you have a supply pressure P and you are connected to the piping and then to the bearing. So the lubricant that passes through the restrictor and then come into the reset. Okay, so you have pressure distribution between the bearing reset and fixed surface. Okay, so you have here the pressure distribution here inside the reset. Then you have a pressure PR inside the reset, and then the flow. Okay, the flow was passing from the piping through the restrictor, and then the lubricant of the oil will go through the film gap thickening between the two surfaces, and the oil will be flow out of the bearing pad. Okay, so the pressure was dropped to the atmosphere. Okay, so that's why we say here the pressure will be dropped to equal to the atmosphere, so zero. The total load capacity for the bearing pad is the recess pressure, the integral between the recess pressure and the bearing pad area. So, and then the lubricant is discussed law lubricant. Okay? 我们一家的这边用的所有的油都是有粘度的油，有粘度的油。Here the next one. Here is a friction service, friction force, F. Because the lubricant is viscous flow, then we will have a friction between the lubricant and the fixed surface. And this one is the fixed one. Okay. So the relationship was depending on this formula. So the eta is the lubricant of is the viscosity of the lubricant. AS is the bearing pad area. So the friction force between the lubricant and the fixed surface using this formula. And the U is the velocity of the flow. Okay. And H is the film gap thickness. The lubricant film thickness. Okay. So as we know, this is a fixed flow. The velocity in fixed flow is zero. And then this is the moving speed for the lubricant. The top is the velocity is u. So we know the velocity distribution for this lubricant using this flow path. 这个是我们流体的摩擦力会用这个公式，这个是跟密度有关。 跟轴承的面积有关，跟它的流速有关，还跟它的油膜厚度。那我们也知道，就是如果我是牛顿流体的话，对有粘度的流体来讲，那流体流动它的解析力就是用这个公式，这个我们常常看到在流体力学里面，一打以上，速度的曲线最高度的那个。所以我们的简切应力是有一个速度的话，我们知道那是我们的速度曲线，速度在固定面这里，在最上面这个移动的速度是通常我们都会把它想象，这上面是一个平板，在流动，它的在移动，它的运动速度是1。这个就是跟我们的工作台一样，工作台如果是打一些那种固定轨道的面，跟我工作台的面之间呈现这个固定轨道是速度的，工作台的运动速度。And then we have an explanation here. Viscosity in the fluid relates to the shear strength to the rate of shear. Look at the illustration of the flow here. So this introduces the unit of the viscosity. For the Newton fluid is 牛顿流体的话，其实 for Newton fluid you have this relationship. 牛顿流体的话，就是有它的简介意义跟结果。For the oil lubricant is Newton fluid. Okay. N 如果是等于1，就是6对，N 不等于就是非常正常。我们的润滑油这些全部都是6对，所以满足这个公式是这个。像一些那个 grease 啊，或者是沥青这些粘稠的东西，那就是非常正常。它的摩擦力跟你的流速不是线性 kinematic viscosity mu. So and mu is equal to 8 divided by the density of the liquid. And another we want to know is the friction, the viscous friction, called the temperature rise of the lubricant. So here is the simple estimation of the effective temperature. Okay. So we have initial temperature plus 0.5 minus 0.5 multiplied by the delta T maximum. And the delta T maximum is the theoretical temperature rise for the lubricant under the consideration of 100% of the heat dissipation by convection into the lubricant. So we ignore the radiation effect. So the heat generated by the viscous friction between two bearing surfaces in movement. So we assume the temperature 100% goes into the lubricant by convection. Okay? So this is the theoretical temperature rise. Delta T maximum we can take it. Okay. Under this consideration, so you will know the T effective temperature is you are overestimating the temperature rise for the lubricant. Because in reality, some of the heat was dissipated by radiation from the oil to the air. Okay? Not 100% of the heat dissipation will get into the lubricant. So you are estimate the heat effective is a bit higher than the real situation. And then we have another assumption using this. Okay. So the delta T, the temperature rise, calculate is using the assumption of 60% of the heat dissipated from the bearing surface was convected to the lubricant. Okay? So this is another different assumption. And this method will give you almost the same effective temperature, which to take the viscosity but reduce the temperature rise slightly. Okay? But in any case, in theoretical calculation, you can use this one by assuming 100% of the heat generated by the viscous friction between two bearing surfaces was connected to the lubricant 100% using this formula. This is the worst case scenario. Answer is calculation. 我们还是要知道，润滑油在经过这个很小的油墨间隙流动的话，它其实会产生高热，高热的话会让润滑油异常，所以我们要去估那个温度。其实润滑油的温度上升，其实粘度会下降，它会影响到你手柄的性能，就是它承载力、刚性。 So here we have a comment here. The temperature rise is high. The viscosity, the bearing will be different from the viscosity of the control device. The control device is the restrictor. So here is some comparison table for the dynamic viscosity. Some viscosity, some data for different lubricant types. So you have air, you have water, you have lubricant oil. So you can assume this is the fluid lubricant using air barrier. And this is the hydrostatic barrier using water as a lubricant. So this is the oil hydrostatic barrier. And here you can understand the difference between the air and the oil. Okay, maybe 10,000 times or 10,000. 34 3,400 difference between the air and the oil. Okay? So for the viscosity, for the viscosity, there is a huge difference between the air and the oil. So the oil hydrostatic barrier apparently will generate a very high temperature rise, while will be high speed. Okay? So the dynamic viscosity is the eta. It's the number of eta. So this is called the dynamic viscosity. Mu is called the kinetic viscosity. So kinetic viscosity is equal to the dynamic viscosity divided by the density. And the viscosity of the lubricant may vary according to the temperature will change. When you are in different temperature, viscosity of the lubricant change. 不同的粘度其实不同的温度，室温下它会不同。通常我们会有一个标志的话，会有一个标准测试温度，这样子的粘度才可以互相比较。那这个当然是因为它导到的是不同的文献上面决定，它的温度标准。除了温度之外，其实压力也会改变我们的粘度的大小。对，这边我们也有写，就是在这个10 每米平方的压力下的话，这个氢的矿物油的粘度会增加20%。所以粘度其实也会有很大的差异，油跟空气就差不多。所以为什么讲这个空气轴承是很主轴，氢气压承都可以 万转，那一静压举头大概3万转可能散热装置的话，大概就是占这个教室空间的一半，因为它密度其实差的非常多。所以前辈密度就差1,000倍。我还记得我们的公数嘛，从它也的。So the friction force is proportional to the dynamic viscosity. And here we talk about different units. In fluid mechanics, you always need to consider the consistency of the unit. 所以我们常常为什么流体力学下高等流体力学在做因式分析，其实我们要去分析它的单位就是一致，在做计算的时候，单位是不是一致，就是可以确认那个推导的过程中没错。他讲的单位的一致就是，so the consistent unit of the force, length, mass, and time. So that's the important thing you need to check. And here is the density. 这个是密度的差，空气、水跟油，这个是氢油，氢油就是我们一般用的润滑油，里面都是用氢油。And also for the air bearing, you need to consider the compressibility of the air bearing, since you are using air as a lubricant. Okay. So the compressibility will affect your stiffening and the bending of the bearing. Usually, liquids are assumed to be compressible for most of the configuration. For the supply pressure lower than 65 bar, usually we consider the oil hydrostatic bearing is incompressible. Okay. Yeah. So if you can guarantee your supply pressure on oil hydrostatic bearing is lower than 65 bar, then you will have the hydrostatic bearing under the situation of incompressible. So to judge the compressibility of the liquid, we are using the Buck modulus of the K. So the V is the volume of the lubricant. So the deviation of the lubricant volume equal to the V divided by K. K is the some modules of system. And dB is the change of the pressure. 所以这个是因为压力变化造成的体积变化，所以这个是我们讲的可压缩性。像我们这个 K 如果是水的话，大概是2.06 Tn m 所以你知道就是对油来讲，65巴以下的话，大部分是我们都会让我的一些那种人工应该讲操作在60巴以下，就是公压 P 小于60巴，那我们就不会有这个可压缩性的问题。如果你还是坚持你的一加轴承要操作在超过公压60巴的话，会有2个问题，一个就是你的理论推导的部分就是要考虑可压缩性，第二个就是你的管路元件都要使用高压元件，不光是你的接头，你的管材都是要用高压元件，通常它的成本就会比原来可能多了20%到40%以上。所以一般来讲，我们在工具机设计的时候，如果是设计一加轴，都会让我们的公压小于60巴，理论上是60巴，大部分我们都让它在60巴以下。So you will see for the hydrostatic bearing product in the market usually the vibration lower than I would say 80% of the hydrostatic bearing product. The vibration will be lower than 50 watt. 事实上，大部分的商品来讲，我会说80%以上的市场上的一阶压轴承的产品，它的公压其实远比理论的60巴小很多，大部分都是50巴以下。When you are going to consider the compressibility, then you need to use the ideal gas relationship, general gas law for this PV V equal to RT. Okay, so the P is the absolute gas pressure. V is equal to the volume per unit mass. Okay, the rho equal to the density. Okay, T is the absolute temperature. So T is absolute temperature, which means that the temperature Celsius multiplied F by 273, then equal to the absolute temperature. And R is the ideal gas constant, perfect gas constant. So this one is the fixed. So R equals to 8.314 joule of absolute temperature, degree K, and more per mole. So when you are going to calculate the theoretical compressibility of the air barrier, you are using this formula. 所以，when you are going to calculate the theoretical compressibility of the air barrier, you are using this formula. 所以，when you are going to calculate the theoretical compressibility of the air barrier, you are using this formula. 所以，when you are going to calculate the theoretical compressibility of the air barrier, you are using this formula. general gas law in this equation. And under different kind of operating conditions, we have a different kind of formula to formulate. Okay? So for the polytropic conditions, we are using this formula. So the constant K is between the 1 to the gamma, or the nu. This one is nu. This is the V. This is the nu. For the air, nu equal to 1.4. So nu equal to the Cv divided by Cv. This is the get a constant pressure and get a constant volume. The heat capacity of the gas. Okay. So for the air, the nu equal to 1.4. So it's getting complicated for the consideration of the compressibility of the air. So that's why we say for the theoretical calculation of the air bearing is more complicated than the hydrostatic bearing or the hydrostatic bearing. Right. Finally, we are going to talk about discuss flow between the two parallel plates. We look at this is the figure. So usually we assume the under plate is fixed. The top plate is movable. Okay. Of course, in the first instance, in the initial consideration, consider both two plates are fixed. So this makes your derivation of the formula more easy. Okay. So first we consider the pressure induced flow. So we have two surfaces and you have lubricant pumping from the pressure supply system. So we have a constant lubricant flow in with the pressure, okay, supply pressure. And we consider a small element in the lubricant. And we have a three body diagram for this small lubricant element. Okay. So we have a equation. First we give you some functions for that. So we have a laminar flow takes place between two stationary parallel plates separated by a thin film. So this is a fixed parallel plate. And this flow is the laminar flow. Okay? You have a presentation of pressure in one end, so pressure is pumping in this direction. And the flow is resisted by the shear stress in the fluid. Because of the lubricant is viscous, so then you have a shear stress shear stress on the top, on the surface of this small element. Okay? And the velocity in the boundary is zero and increase to a maximum at the center of the system. The pressure across the floor is assumed to be constant. V pressure. That is dV divided equal to zero. Okay? Which means the pressure inside is film thickness. The film thickness is H. The film small, I would say a thin film, very small film thickness. So there is no pressure difference between these for the different heights, which means the pressure is constant in this thin film. Okay? So that's why you have this one. If V is y equal to zero, so the pressure will not change at the different height. So this is the x direction, this is the y direction. And here we have a force equilibrium of this element. Okay? And we have this element with V and V in this vertical direction. 所以我们有一些假设啊，两个固定平板，它是一个活的油墨。那假设在这个活油墨之间，它的压力都是固定，都是一个固定，它没有变化在不同的高度上。假设那个元素的厚度是 d， 所以我们这个是 x， 这个是 y 方向，所以可以把这个是 z 方向。那它厚度的大小就是 g。所以这个元素的力体呢，我们可以把它找出来。所以我们看这个是 x 方向的力体，这个的面积是这个长度是底 y， 厚度是底 d， 压力等上面积就是它的力，就用在这边。我们在看水平的力，上面这个力，乘上它的厚度，这一个乘上力，方向一样，然后负的是水，凹底 x， 乘上那个厚度。另外是这一边，这个也是反方向。一加上底 b 除 dx delta x delta y multiplied by the v okay, minus direction. So all the forces in the x direction, the summation of force in x direction should be equal to 0. Why? Because the lubricant is moving in constant speed u, so there's no acceleration. Okay? So that means you have a force balance. Because the velocity is constant. So is not equal to zero, which means that we can use Newton's second law. You will have an acceleration, okay? Because your speed is constant, so your acceleration is equal to zero. Which means you have force current equal to zero. Okay?流体是用附近的数字 u 在做流动，它没有加速，所以没有加速度就没有力，就表示我说的流力是等于零，对，所以就满足我们的力平衡。And then we will have this first formula, okay? And you have the boundary condition for the two boundary conditions. Du dy equal to 0 and y equal to half of the field thickness. The first one is the first boundary condition. The second boundary condition is that at this fixed place, the y equal to 0, and you have a 0 velocity. Okay? So in this case, you have this pressure distribution for your viscous flow. 所以你把边界条件再继续解刚刚的偏微分方，两个边界条件再继续，我可以解出这个速度分布的曲线的方程式。So this is the velocity. Velocity multiplied by the cross section of this plane. 我们有速度曲线，我们有它的前面系，其实是可以算流量。流过我这一个平板之间，我们可以 calculate the flow rate passing through these two big stationary parallel plates. Using the velocity profile multiplied by the cross section area between these two plates. So you have this volumetric flow rate, okay? 这是它的流量，体积流量。Okay? If you multiply this volume flow rate with the density of the fluid, then you will have a mass flow rate. Okay. So 我们现在就可以算出两个平行板之间它的那个体积流量跟质量。因为我们要估算每一个轴承每分钟的流量是多少，那我有好几个轴承，我们把它加起来，就是我公有系统总共出来的流量总流量，我的公有系统出来可能要供应5个轴承，每一个轴承分别是一个流量，这个一线二轴承的系统就是这样，我这个工具机上面用了几个鼓吹轴承。用几个周期轴，我就把它的每一个单独的轴承计算，把流量加起来就 有公有系统的总流量。Okay. So this is the configuration for the flow rate. You have the volume flow rate, you have mass flow rate. The difference is that for the volume flow rate multiplied by the density, you have a mass flow rate. So this is the design of your system, every system. You need to know the flow rate. So this symbol is not flow rate. Here we have and usually in the other book of the hydrostatic equation, usually they are using this symbol and form. Most of the textbooks were using this symbol. But in any case, in our book, it's using the. So this one is equal to this one. This is called mass flow rate. Okay. So usually we will add another term rate. This is the volume flow rate. So when you look at the other textbook, this means the same. Okay. 别的教科书比较常用的是这个，我们用的符号也是用 S 报，然后它是质量流率，上面那个也是用 volume flow rate 体积流率。Okay, and this formula applies to the both liquid anticipating unit and also aerostatic unit. It's the same. So that's why the author is written the sample to discuss the hydrostatic unit and aerostatic unit. So the formula is the same. Although the value of the viscosity or the loop or the other densities are different. So here are the practical terms. If you are applying oil hydrostatic bearing, you are using this formula. If you are applying aerostatic bearing, you are using this formula. Okay. But the original termination of the formula. So 这个是一气压的用，原子的公式是一样，是边界条件，跟我们给的一些条件不太一样，跟不太一样的公式。So here we have we increase the flow. I mean the flow rate increase. The flow rate increase is proportional to the pressure difference. 压力越大的话，它的流量就越大。这是个 final conclusion. you have any questions? Because we have 1 minute.所以其实理论推导的部分，你刚才就只看到这个公式的部分，流量是第一个要推的地方，所以气静压跟液静压融合其实用的公式是一样，都是叫静压融合。为什么？以前1990年之前，这部分都叫静压融合。当然，我们考虑的是最简单的平行法，这两个是。到时候更复杂的平行板就是下面固定，上面是动，就跟我们的直线工作台一样，固定轨道是固定，工作台会动，它有一个额外的系统。那还有一些的话，像动压轴承其实是歪斜，我这个板子就不是平行，一样可以推导，都类似的东西。我们先介绍到这边。有什么问题 ？Any questions from today's lecture? So if there is no question, the lecture today will be concluded. Okay. I will see you next week. 下礼拜再见啊！今天就上到这边。好，有没有签名的？签。